Okay, I think we are back, so I do apologize for that. My internet completely died. So basically what I'm doing now is implementing recursive Fibonacci in the assembly. So let me look for a good example of Fibonacci, and I did spell it wrong, so that's great. Let's see, is this a good example of it? Dun, dun, dun. So it's pretty simple, Fibonacci. Yeah, so we have something like this. So this is Python code, it looks like, or Ruby, I suppose. So if the number is less than 2, then return the number. Otherwise, return number minus 1. Alright, so I think we can do that. So basically, we'll do fib. Yeah, and it is with 1b, so I don't know. Yeah, I messed some up. So basically, we have the number on the top of the stack, so that is what we're assuming. So we'll push 2, and then compare less. Yeah, less than, compare less, and then we need to jump, so 0 jump. So that means it is, hello there, Tanish Solanki, if I pronounced that right. Yeah. How are you doing? How are you? Alright, so 0 jump, so that means it was not less than 2. Then we'll jump to else, basically. I think we can just call it that. So we'll have an else here. Otherwise, this is if it is equal, then we will just return with the number on the top. So we do need to duplicate the number, actually, because compare, let's see, does compare consume it? Let me check. I don't quite remember. Compare like this. Yeah, so we pop it off, and then we push it back on, though. So, I suppose it does not consume it. So I think we're fine. We don't need to duplicate it. So yeah, then we'll return, and that will just return the number. Otherwise, this is the else, which isn't a keyword, it's a label, actually. Otherwise, we will do number minus 1 plus number minus 2. So how can we go about doing that? Let me think. So we have the number. So we can push 1 and then sub. Let me duplicate the number now, because we actually do need to. So we'll duplicate it, and then we push 1 and subtract. And then we basically do call fib. That is with number minus 1. And then we'll dupe again. And then we'll push 2, and then we'll sub, and then we'll call fib. Yeah. And then we can return at the end here. And do we need 2 returns? I don't think so. So I think that is what we need to do. I might be doing some stuff wrong. So let's call fib down here. So let's make this main, and we'll actually make an entry point at the top here. Entry point main. There we go. So call fib. So let's actually push a number onto here. Yeah, so this is just, let's see. We'll push 10 there. Okay, and then let's build it. We didn't need to do that, but so test slash recursive fib. Whoops. Is it not in text? Let's see. Test slash it's fib ray. There we go. Alright. So fib q. Not sure what that's about. Oh shoot. Did I actually, something might be broken. Cause fib q. So then native 60. Okay, yeah, so something was broken. It's reading one too many bytes, and that's where the Q is coming from. So I will need to fix that, but fibrec him. Alright, and it didn't do anything, because we never actually print it. So, yeah, we should probably do that. Okay. Yeah, so we need to print the number. So I will use print for this, for testing purposes. Yeah, so I'll just print it right here, but then we'll change it to write syscall. So basically, we need to print it. Do we print it? Let's see. Let's try there. So that'll be at the end. So I don't think that's what we want exactly, but it doesn't print anything. So, yeah, so it's not actually working. Let's print it up there. So let me dupe it and then print it and see what we get. So we get 1, so 10. And then, let's see, is this actually, alright, 1 and then 0. 10, 1, 0. Okay. So, let me see. So we're checking if it's less. And then, yeah, if it is less, then we push yes, which is 1. So if it's 1, then we want to just continue here, and then we return. Yeah, so... Okay, what is that slash wall or dash wall dash extra in terminal? Yeah, well, I can show you. So I have build.sh here, and basically it's flags for the compiler, so that basically it just means warning. So the W means warning, and then all means all, but it's not actually all. So then the extra is to get the extra one. So basically, yeah, it's just to enable more warnings. Because certain things won't throw a warning, even though, like, so basically you can make sure you're doing things a more proper way. That is the point of it, basically. Yeah, so it just means more warnings, essentially. Yeah. Okay, so one sub call fib, do fish two sub call fib. So let me see. Let me move this actually to right there. And then, all right, so we only get 2. So, when we get to 2, it does that. So if we make this just 1, then we should get 1, right? No, we get a stack overflow. Okay, so then it gets stuck in an infinite loop. So that is not good exactly. So how can we test this actually? To do that, does it still? No. So it prints 2 again. So good. We need to actually pop the 2 off. So yeah, we need to pop right there. That is an issue actually, because it is putting 2 on the top of the stack. Okay, so now we get 1. Yeah. So if we now move this right here, and let's make this 10. Okay, so now we are getting something at least. 9, 8, 7. So this is just a countdown now, I suppose, is what it is doing. Negative 2. So it's counting now. Then it goes down by 2. So yeah. All right. So must be doing something wrong. Let's see. So I'm not used to working like this in this sort of way. So I'm learning a lot here. So I do apologize if make some mistakes. Yes, we have 10, and then it just counts down by 1. So we need to actually add these. So how would you do this, basically, is what we need to do. So we need to add the results of the function calls. So, okay. That should be add. Yeah. I understand. Well, so we need to subtract here, but we need to add the results of that, is what we're doing, basically. So we are subtracting. Like this, and we need to do that. But then when we return from it, we need to add what is on the top. So can I do that just here? Add. Okay. Okay. 8, 7. So we're getting somewhere at least. It's different. That's good. So 0 and then 2, 3, 4. Okay. So yeah. So maybe I need another return actually. Do I need to return here? Okay, so that presents the 0, but that's actually not what we want to do. So, trying to follow the logic here. So basically, we have 10. So that's what we duplicate here. Duplicate, so we get 10 and 10 on the stack. And then here we're just putting out, so it just becomes 10. And then we have 10 and 2, and then we compare them. So 10 is less than 2. Is that actually the order that we do it in? Yeah, so we're good with that. So 10 is less than 2. So if it is less than 2, then we pop the 2 off the stack. So we just have a 10. And then we return. So we just return the 10. Or, no, we wouldn't have a 10. Because, obvious reason. So if it's less than 2, so if it's 1, then, yeah, we return just a 1. Yeah, so that's all good. Otherwise, we do still pop it off. So then we have 10 and 2 here. Then, then we get rid of the 2. And then here we have 2 10s. We push 1, and we subtract them. So we have 9. Yeah. And then we call fib with 9 this time. So this time it goes here, and it... Yeah, so that is actually where the countdown is coming from. Yeah, so maybe I want to change that kind of. Let's see. Let me call it just right here, then. 2, 2, 2. Okay, so then we just get a bunch of 2s. So that is something. let's see, maybe right here. Alright, it's still just 2's. Let's see. So then it's 0. And let's see, what do we get after this? 2. Alright, 2. So okay, well let's see then. This. So yeah. Let's see. So we have 9 here. Let's keep going through this. Then we duplicate the 9, or actually, then we get so then we have 9. But we want to add the 1 back, right? Yeah. So actually, this can be 1 and again, and then yeah, it's the same as removing. Okay. Yeah. That makes sense to me. Stack overflow. Okay. That's a little weird. But then we have 9 and 9, and we have 9 and. So I guess it doesn't go down when we do that. Yeah, because then we have 9 and 1, and then it becomes just 8. We call it with 8 this time. So it doesn't go down enough when we do that, I suppose? No. It's because we dupe it, actually. So, we want to pop this off, actually. Now that I'm thinking. Because we have 9, so we duplicate 10. So we have 10, 10, and 1. Yeah, that's okay. Then we have 9 when we sub it. So we have 10 and 9 on the stack. And then we call fib with the 10 and the 9. But yeah, we basically, it's only utilizing the top of the stack. So the 9. So I think we do need to pop it, actually. And I don't think we need to do. No, we do need to do. And then we have the 10, and then we have 10 and 10. And then this still needs to be 2. Okay, so now we're not printing anything. You don't have any prints. Let me just do here. Dupe and print. Let's see. Okay. Well, so there is some sort of pattern. Not the right pattern, but it is a pattern, and it goes for a long time. Because it takes longer to get down. So, closer. Let me actually move this back down here. So what do we get there? 30, 20, 12, 6, 4, 9. Okay. Yeah. So there is patterns. There is patterns. So let's look here. Actually, I meant to do that. Let me see. Right there. Okay, so. So let me reference the other Fibonacci that we have, fib.taxon. This one, yeah, so actually that's not going to be very helpful. So let me look here, right there. What do we get? After the pop, actually, because we don't want that. Okay, so yeah, so that's the pattern. What if we make this a smaller number? So if we just make this 1, then yeah, it's not going to print anything because we don't actually have that. So in here, right there, actually, if we print it, then we get the 1. So yeah, that is all fine. And then here, if we do 3, then it's going to go through a couple different iterations. So we get the 2 and the 1, because it's, well, so I'm not, where does the 2 come from, actually? Where, so yeah, why do we have 2? Because if it's compared less, it shouldn't be. Let me see this, actually. Why is it as float? That might be a problem. So, and then x like direction. Okay. So it doesn't change anything. Let me just change that back. Because I don't remember why I did that exactly. Alright, so why are we getting 2 though? 10 is less than 2. Yeah, but if it's 2, it's not less than 2 still. So it should be 0 still. So we shouldn't be printing 2 here. We're getting the nth term of fib sequence. Well, yeah, so I'm doing basically we are returning all the numbers is what I'm trying to do. All the numbers, like the same as this one, but recursive. So not the end term, the like up to that point basically. Yeah, if we look at this one, I need to go into there actually. We're doing the same thing that this one does. There we go. Fib 10. Yeah, so just like this. This is what I am trying to accomplish. Yeah, so if it's less than 2, then we return it, right? Yeah. So like 0 and 1 is less than 2. Then if it's so that's 0, this is 1, that's 2. So if it's 2, we need to return 1. So we subtract 1 from it, and we add them together like this. Yeah. That's what I'm trying to do. Yes. Right? Okay, so yeah. So I'm trying to understand why it's printing 2 here. Because there should not be a 2 on the stack. Yeah. So when we print it, like if we, so if I push 2 here, yeah, so then it prints 2. Yeah, so this isn't actually working. So something is wrong here. This is what we're using. So is it not compiling to the right term? So let me actually, whoops. Let me print out here. A and B. Alright, and that is, alright, I need to change this as int, and then this needs to be LD. There we go. Alright, so now if I try to run that, yeah, so 2 and 2. So and then alright, yeah, let me actually look at them as floats. Because that's how we're interpreting it. I may need a separate compare for floats and integers. That probably would make sense. Well, actually, there was something else I was thinking of that might be better than that. But yeah, so let me just look at this. So this is a float. There we go. Okay, and if we run that, then alright, so they are 0, so that is an issue. So but they're not the same. Okay, are they, so it's returning 0 for that. But it is still printing 2. In the base condition, it should return n minus 1. Ooh. Oops, that's the wrong one. In here. Oh, okay, so like that then. Wait, that can't work. Okay. Oh yeah, because we printed it before we do that actually. Okay. Well, but if it's 0, we want to return 0, 2. Not -1. So yeah. So that needs to be a separate check then. Yeah, so if we push 0 and then compare equal, or compare less, I suppose, is probably better. Else 0. Not 0. Yeah, so then let's put not 0 here. Whoops. Yeah, so if it's not 0, then we'll do that, and then otherwise we can return, because we can pop and return. So it'll return 0. Well, actually, we need to push 0 and return that. So we'll pop and push 0, because we want to return 0 in that case. And it still returns -1. So actually, compare less than equal. Is that right? Okay, so yeah, now we don't print anything because right there, and yeah, so that is what it returns, 0. So that is good. Yes. So let's make this 1 now. Okay, 2. Okay. 2 returns 0. So, oh yeah, because we return, yeah. So I need to add down here as well. Let's see. So I need to put this in the right place. Whoops. Right there. Okay, let me start with 10 here, because that's what all the comments are. So we print 0. Yeah, let me do that. So, oh yeah, we need to actually pop the 0 off as well, right there. There we go. Okay, so now we have that. But then, so, condition doesn't handle n equals 2 case. Ooh, okay. So, let me, let's look at all the Fibonacci numbers. Is there just a list of numbers? Let's see. So is this, yeah, all right, right here. So 0, 1, 2. So 2 should return 1. Okay. So yeah, so this can just be equal to, and then that should be fine, right? Because then we subtract 1, so that's fine. Because this is the 0th, so we return 0, right? Or is that not right? Or is this the first one? Okay, I think we're back. So my internet went out again. That's like the second time it happened today. So it happens again. I'm just gonna end the stream and stop there. So yeah, let's see. I'm gonna look at fib recursive. I'm just gonna find a different example that doesn't use Ruby or whatever. Like an actual one. Let's see. Let's look at that. Yeah. So so here we have Fibonacci. So you need, yeah. So return 0. Okay, so if it's 0, then we return 0. If it's 1, then return 1. So basically, if it's less than 2, we can just return that index. And then otherwise, we return n minus 1 plus n minus 2, or return the Fibonacci of that. So basically, let's say it's 3, right? Then it's going to return 3 minus 1. Yeah, so that would be 2. So 2 in here. Let's say it's 2, actually, because that'll be easier to process. So if it's 2, this would be 2 minus 1, right? So we would call that. So it would be 1, and then return 1. So this would basically equal 1, right? And then here, it would be equal to 0. So it'll just return 1. Yeah. So we could do that. So now let's look at 3. So n minus 1. So 3 minus 1, so that'd be 2. And then 2 and 1. So then the 2, we know that that became 1. And then 1 becomes 1, so it's 2. So that is, let me look at the sequence. So, yeah, so 0. So the 0th one is 0. So that is actually, and then 1 is 1. And 2 is also 1. And then 3 is 2. And 4 is 3. So that, we need to keep track of that. So let's look at 4, actually. Just like that. So, yeah, so obviously that's not right. So I think that is going from this way. So I'm not sure which way it's going to print. But yeah, so we want this to basically look the same as this, right? That's kind of what we're hoping for. Yeah, so it's gonna be like this. So I need to figure out how, right, how the calls work. So how to add them, kind of, basically. Because we have this here. So, whatever is on the stack needs to be added together, essentially, on the stack at the end. So, yeah, so it's something like this, I think. We add them, and then do and print. So, not quite that, though. So, yeah, we're pushing 1, and then subtracting. So, yeah, if there was 10, it would be like this. We'd have the 10 and the 9. And then we call the fib with 10 and 9. But then when we continue here, we want to swap them. So it becomes 9 and 10. And then we push 2 and we subtract from it, so then it's 9 and 8. And then we call fib with 8. And actually we have 9 as well up there. So we'd have 9 and 8. And then, yeah, so we don't want to add 9 and 8 though. So, but that's not... So when we return from there, it returns a few times. Because, yeah, so where do we want to... Do we want to return actually after each call? No, yes, that's not right. I'm trying to think about how it would work. Yeah, we just want to return at the end because we're setting up the stack for each of the calls. So, let me see if I can find actually in assembly. And if there's like, well, then we can kind of compare it. Yeah, this probably doesn't. Does this have assembly? Okay, so this is, yeah, I want like, x86 and that is an assembly. Yeah, like this. So, yeah. So we have that. Fibonacci. Then any fib function will return. So, let's see. So here, we're setting EAX equal to n, okay? And then if n is less than 2, then we jump to the end function. Okay, so actually, that's probably a good idea to add keyword for that. So basically, end, yeah, we'll just call it end fib, I suppose, end fib. And instead of return, we'll just do, yeah, we'll do jump to end fib. Oops, yeah. So, and, yeah, so here, do we want it there? Yeah. So here we can just do, yeah, else, and then we'll jump to end fib, like that, I think. We do need to pop at the end fib, though, right? Yeah, this isn't fib anymore. So we can do something like that. I believe. So then this can just be like that. So let's see. Alright. We actually underflow when we do that. Maybe we don't want to pop. Maybe we want to just pop for this one. Yeah, it's like that. Perhaps. Whoops, actually, did I move the wrong thing? Yeah, I moved deep up here, not pop. There we go. Okay, yeah, so now that's the same sequence as it was before, but yeah, that is better. So that is something good. And this is just for printing, do print. Okay, so we compare. It's less than 2, then you jump there. So that's what we're doing. And then we push n minus 1. Okay, so else pop. So do we need to pop here? Because we do have the 2. So I feel like okay, so that's fine. We pop here. So then it just becomes the 1 number. And then we duplicate it, and we want, yeah, we push 1 and sub. So that is the same as pushing n minus 1, essentially. It's a bit more, what's the, I'm not sure what the right word is. Yeah, whatever. So call Fibonacci. So returns EAX. Equal, alright, so do we need to do that actually? Okay. And then here, EX equals n minus 1. Alright, so I don't know what that means exactly. I don't know assembly well enough. Alright, we'll then push n minus 2, and then call it. So, yeah, so that's what we do here. Do we need to swap it? Maybe not. let's see, if we get rid of the swap, it's almost the same. Not quite the same though. Okay, so get rid of the swap, push 2, and then sub, so that's that. And then call fib. Yeah, so returns that. And then add. And then add again. Stack overflow. Okay. Ooh. So why would it overflow from an extra add? I'm not sure. Oh, because then it never gets to be 0, right? 712. Okay. Yeah. Alright, well, let's work through this. Back on the floor, yeah. So, yeah, then this just becomes nfib, so we don't need to call it here. Or jump to it, rather. Yeah, jump nfib. So, yeah, so that, doesn't work. But what if... And if I get rid of that, and get rid of that, then, yeah, it does that. So that's interesting. So, right, okay. So 7 comes from adding these numbers. Okay, so at the end of it, we just want the one number to be on the stack, though. So that is the thing that we need to remember. Okay. Yeah. Stack-based programming like this can be kind of confusing. Alright, well, let's see. So if it is, it's 1, then it should just return 1. Yeah, just like that. So that's expected. Let's see. So then if it is 2, then we want it to return 1. So that's obviously not right. Yeah. So let's kind of work our way through it like this. Okay. So that doesn't change anything. So, the comments kind of are making it confusing now. Whatever, it's fine. Yeah, so push 2 and compare it, and then, yeah, we pop it off. We pop it off here as well. Duplicate it, okay. Push 1 and sub. And then, yeah, so we call fib. So when we call it, then the stack stays the same. So we have 10 and 9, but then we jump up to here. So then the stack, yeah, so now the stack has 10 and 9 and 2 on it. And then we compare them. Yeah, so yeah, we compare it, and we go here and we pop it off. So we have 10 and 9. So it shouldn't matter what's on the bottom of the stack, because it's only supposed to have 1 anyway. But yeah, then we have 10, 9, and 9. And yeah, 9, 9, 1, like that. And we subtract it. So then we have 10, 9, and 8. So yeah, do we need that though? Okay. 10, 9, and 8. 10, 9, 8. And we call fib with that now. So now we have a lot of stuff on there. So then we have 10, 9, 8, and 2. We compare that again. 10, 9, 8, and that's it. And then duplicate it. 10, 9, 8, 8. Yeah, and this is 10, 9, 8, 8. Whoops. Nope, nope, that's not what I want. 8, 8, and 1. And we sub 10, 9, 8, 8. So it becomes 7. Okay, 10, 9, and 7. And then we call it again like that. So perhaps I should have started with a smaller number. So let's just imagine it's a smaller. So let's do 2 actually. Let's see what happens when we have 2. So we do 2 and 2. And it's not less than 2. So we go here. And then, yeah, we pop off the extra 2. So we just have 2 on here now. 2, and then we duplicate it. So we have 2 and 2. And we have 2 and 2 and 1. And we subtract. So 2, 2, 2, so it's 2 and 1. Call fib again with 2 and 1. And once we come back here, so we have 2, 1, and then 2 again. And then we compare if it's less, and it is. So then we have 2, 2, 1, and then that's it. So we jump to end fib, and then we return. So then we get back to here. Back to call. Except we still have the 1 on the top. So yeah. So we have the 1 on the top. So do we need that extra 2 on the top though? We probably do though for the next one. All right. Well, so we have 2 and 1 now on the top. Yeah. So 2 and 1, and then here 2, 1, and 2. We subtract, so we have 2 and negative 1. So yeah, we do need to swap it actually. Swap, and then it becomes 1 and 2. So we have 1, there we go, and then it's 1 and 0. 1 and 0, and then we call fib with 0, so it just returns 0. So yeah, we have 1 and 0 again. And then we add 1 plus 0, and it should print. Okay, so that seems to make sense to me. I forgot the comment. There we go. So yeah, but it just prints 2. And it shouldn't print 2 at all. Well, it does print 2 when we get to 3, but we're not at 3. So it just should be print 1, because that's what we have here, 1 plus 0. That's what it should be. But it's not. So we need to figure out why. So it could be a problem in here, or it could be an actual problem with how we're handling things in the virtual machine itself. Okay. Yeah, so we shouldn't ever get here with 2. So that doesn't... But it should print... Yeah, so... Let's make sure we're actually calling. Yeah, in here. So let me just hit F, Cobb, and we should see that a couple of times. Called. Okay, so we just get it once. So yeah. So this is calling. Well, no, because we just, yeah, okay. So it's not calling that actually. Yeah, because it's the first call down here actually, when we call fib like this. Yeah. So we call it, and then we're here. Can we print the stack actually on each iteration? Maybe that will give us some insight into what is going on. Let me yeah, Yeah, right here. So we'll just print stack, and then I'll see sort of what's happening. So actually, let me go back, rebuild it. All right, and then we'll run it again. So yeah, so this should sort of show what we've got. So these are just like the jumps. Here we push the 2, and we call fib. Yeah, call fib, and then we have 2 and 2 on here. Yeah, and then then we have 0. So yeah, so we have 0, so it consumes the 0. Then we have 2 and 2, and then we're just back to 2. So that is right here. Then we have this. So it should go right to 2 and 2. So that's a little strange. But yeah, okay. So 2 and 2, like there. And then then we get rid of the 2 again. So why does that happen? Okay, so something is not right here. Something is definitely not right. Let me see. Are we having a lot of these instructions? Because that would indicate something is wrong. So we do have a few from the latest, because that's what they sort of transform into. Let me just do that again. Alright, so if we run it, so we have 3. Okay, so that's actually probably fine. So yeah, that's probably fine. So here we have a not. Okay, so 2 and 3. Okay, so that is fine. So this is probably the first one. So this becomes a no. And then this is well. So that is where those are coming from. So I am fine with that. So that doesn't seem to be the issue. Let me rebuild it actually. And alright, so but things are still not working properly. Like we can kind of figure out where we're at, but so we print this and then end stack. And we have 2 again. So like, because we call it. So we call it and then it stays 2. And then we have the note here and it's still 2. Whoops. Yes, we have 3 2s, so that is fine. And then we have the 2 2s, so that's when we get there. Then the 0, because that's immediately following. And then we pop that off up there. So from right there. But you know what? Then it's jumping to end fib, isn't it? Maybe not. Hang on. So 2 and 2, and then yeah, if we pop it off here. So is this? Does it think that this is true? So is it? Oh shoot. Is that no? That's not what we want. So if it's not 0, then it's false. So yeah, then it goes forever. So that's not good. So it's recognize that it's 0, of course, because we pushed the 0 on there. Yeah, because we see the 0 getting pushed on. That's right here. Which means false. So if it's not 0, it jumps to else. Oh, if it is 0, we want to. Okay. Okay, that is so less than. So less than. Then we want to go there. Yeah, so actually it thinks it's less than. Okay, hang on. Let me get rid of this. Yeah, hang on. That's not quite right. This is a bit strange. So, yeah, so it thinks, so if it's less than, it would push 1 onto there. So this should be 0 jump. But then we get a stack overflow. So, not sure why. Yeah, so I'm not sure why that would be exactly. Alright, so let me print the stack again. So, there we go. Yeah, so run that. So why does it go for it? So compare less than. That's going to push a 0. And we want to jump to else if it is 0. But if it's... So... Zero, one. Yeah, this is not quite right. Yeah, so this should be compare less than. Is it the wrong order? Is it the wrong order? So here we pop off A. So whatever's on the top. So if what is on the top is less than the other one. So we want to do that in a different order, actually. We need to swap. And then we compare it. But then we need to swap before we pop. Swap before you pop. Yeah, like that. So actually, let me change back to 2. 101. Yeah, so we need to do that because, well, we could just do greater, I suppose. Greater. Well, hang on. So if it's less than, yeah, we want to 0 jump to else. Because that means it's not. Yeah. Okay. Yeah, but if we use greater, then that is if 2 is greater than that. Yeah, so then we don't need to swap actually. Yeah. So, but this needs to be like that. There we go. Okay, so let me actually just do it this way. It's easier to process. Okay, so 101. So that's not what we want exactly. Because we do. So actually, maybe we don't want to do that there. So at the end, let's print the stack now, actually. Stack. There we go, right here. Build that, and then, so we can see what, we can walk through what's happening here. This seems to be a lot. Okay, so we have 2, yep, and then we go through these. We have 2 and 2, 2, 2, and 0. Pop off the 0, and then we have 2 and 2. So, yeah. 2 and 2, and then we just have 2, so we pop it off again. Okay, and then we push another 2. Alright, so that is where we are. Then we push a 1. And then we subtract it, so we have 1 and 2. 1, 1. And we have 2 again, so that's up here. we swap them. So we have 1 on top and 2, and then we compare them, and it is true. So we pop it off, and then that's what we return. Yeah, and then we return, so we're back to here. We swap them again. So 2 is on top, and then we have 1. 2 is on top, right in here. Yeah, so 2, and then push 2 again. But we need to swap it first. 2, 0, and 1. And then, yeah, when we add those together, it should be 1 plus 0. Then we have a 2 again. For some reason. So, for some reason, we're here now. 2 and 0, 1. And then we have 0 and 1. So that's what we want, to add those together. And then we have 1. So, yeah, that is what we want, really. Okay. Yes, then we have 1. So that is the, yeah, this will just print the nth number, right? So, alright, yeah, and that doesn't print anything. Four, and then 3. Okay, and then 5. 5 is 5. Alright, so then 6 should be 8. Okay, so actually, it's almost starting to work. So we can get that number, but then we aren't listing the rest of the numbers properly. So 8 is 21. Yeah, so we can get the nth number now. And it prints it out, but it also prints out the extra ones. But I think we could do that just by, yeah, well actually we don't need to duplicate it here, I suppose. Yeah, so this way we can get the nth number. So that seems to work now. Let's get the 17. 1590. Alright, so let's see. 17. Yep, alright, so that is working. So we can get the n. So now we just need it to work to get all of them, basically. So we could do a loop here. Loop kind of thing. So basically push the number of loops that you want. In this case, push inside there. And then yeah. So we do that. And then we can compare, let's actually set loop here. Compare equal to 0. Actually, no, we push 0, we compare equal. And then 0 jump to n. So this is the full n, where we exit. There we go, like that. So 0 jump to n. Let me indent this so it is all a bit more clear. So this isn't part of the loop actually. So there we go. There. Okay. So we have the loop. Push 0, compare, and then 0 jump to n. Otherwise, we push. Well, so that's the number that we're working with. So we don't want to push that in the loop. Because we want to subtract it each time. So we can push that right here. Yeah. So maybe we could actually just keep track with the number. So we do that, then we compare it. 0 jump n. And yeah, otherwise we pop it off. So because that'll pop off the extra 0 that we have. And then we just have 10. So we call fib. And that's gonna return stuff. So we have to dupe before we call it. And then at the end, yeah, actually we can print it, and then we can push 1 and sub. And then jump to loop. Alright, so this might not work. Yeah, okay, so it didn't print anything. So, and it did exit with 1. So let me make it a more random exit so we can make sure that. Yeah, okay, so that is just jumping there immediately. So, want to not 0 jump to n. That is the issue. Okay, so now 1, 1, 2, 3, 5, 8, 13, 21. So is that 7? 7 is 13. So we actually go past what we want to. Oh, because we go to 10. Yeah. 10, 55. Okay, so we can print them out. We just don't have the 0th one. So actually, okay, less than. Yeah, okay, so now it doesn't work. So that's the way that one. There we go. So now we do Stack Overflow. Ooh, okay. That is interesting. So why are we overflowing now? So we compare greater. Hang on. Yeah, so that. So, hello, Mr. Yes, hello there, Anthony Slab. How are you doing? Or Anthony, how do you pronounce? Is it like Ethos Lab, where it's the lab, or is it like Etho Slab, Anthony Slab, like a slab? How do you pronounce it exactly? Kind of sounds the same, no matter how you pronounce it. But yes. Wait, I didn't start Pipewire. Pipewire. Wait. So does that mean you can't hear? I don't know. Okay. Yeah. So we print out that it works now, but we stack overflow. So perhaps if we print the stack on each iteration. Yeah, right here. We can get an idea of sort of what's happening. Actually, we need to rebuild it. And now we can see. Yeah, okay. So why does it do this? That is a bit interesting. So what if we do something like that? Yeah, it still does that. Hello again. Okay, I think I'm back. So my internet died again. Yeah, so it's probably gonna happen again, I guess, and then I'm gonna just stop streaming. But yeah, I guess it doesn't want me to stream right now. So I'm just testing some stuff. So if we pass -1 to this function, then it actually stack overflows. And I think that has to do actually with the float. Yeah. So in the compare equal, we're actually interpreting as a float. So if we change it to as int, actually that's an all of them. We do that. So yeah, let me try to interpret it as int. Yeah. Okay. It's int. Okay. I guess I could have query replace with this, but now I'm almost done. So, so that's actually the issue. So, I'm assuming it is. I don't know for sure, but we will in a moment. I think it's the last one. Nope, there's one more. Okay. So, I will actually discuss a fix for this in a moment. Yeah. Okay, there we go. So that's good now. So we rebuild it, and now we run it, and it doesn't overflow. Okay, perfect. So that was the issue. So it's floats. Floats are the issue. Floating point numbers. Yeah, so let me not do that anymore. Get rid of that, and there we go. So now if we actually run this, now it doesn't work at all. Okay, there we go. So we do print the -1 then. And we don't want to do that. So, okay. Or equal to, there we go. Well, so actually, let me just swap and compare. Yes, there we go. Nope, alright, so that's not right. Alright, there we go. So now it is what we want. Okay, so now we can print the first nth Fibonacci numbers. Yeah, so that is actually the correct order. And here we have push n, so we can change this to be 30, for example. If we run that. Ooh, that's pretty slow. Yeah, so the recursive one gets kind of slow. But that's okay. So let me actually time that. Because we can compare that directly to our iterative one and actually see the difference. So let me do fib.tasm. Yeah, so that's the one that we're going to compare it to. So we can time this, and yeah, so we can see it takes a while. So it actually takes 2 seconds. But then if we run the let's see, tasm fib tasm, fib tim, there we go, and then time it actually, and it happens almost instantly. But something that we are using is we're using print here. So if we actually convert this to be right, so I think we can do that by doing int to stir, and then right. So actually that's native 1, so push 1, and then I think that should work. Right, hasm. Yeah. So int to stir doesn't work. What is it? Int to stir. So that's right. So it doesn't like this. Is that in the... Yeah. Okay, so that is actually defined in here. So we need to import that in here. Right here we need to do at import standard depth.catch, and then we should be able to do it. Direct 10. Oh dear. Okay. Yeah, we didn't print the new line. So let me push /n. I'll do that like that. Maybe a 4. Okay, and then we want to write /n as well. So yeah, we can do that. Into assert, push 1, native 1. So actually this can be right now because we have that. Mr. Cobb, ye back. Yeah, sorry, my internet completely died. And actually that's like the 5th time it's happened today, while I've been streaming, so it might happen again. And if it does, I'm gonna just end the stream. Yeah. So I do apologize for that. Yeah, so right, and then we can get stir 0, push 1, and right, and let's see what happens now. End it. Yeah, I'm gonna end it all. End it all. No. Ooh, okay. That is 3.6. Okay. 3G. Okay. Profound string. So it doesn't like... Oops. Doesn't like the string that I'm doing up here. Because this needs to be push stir. There we go. Whoops. There we go. Okay, and it didn't work actually. Okay. Oh, I seem to have gotten rid of it by accident. Yeah, so let me try that again. Stir 0, push standard out. And then right. This can be standard out as well. And then down here, this can actually just be exit. Like that. There we go. Alright, so let me try that again. Yeah, you can see it's not very fast. So if we time it, I think it, let's see, it is faster. Yeah, but it is rather slow. Especially, yeah, again, comparing it to the iterative one, which happens almost instantly. So, yeah, so that is the thing, for sure. But yeah, so this works now. I don't think I need to rename anything. Let me actually indent all this, because it is all in here. So that looks better. And then, so I don't think there's anything I need to do for that. Let me get rid of the comments, perhaps. Yeah, if I just do something. Whoops. I don't know what I did there. There we go. So, yeah. Oh, don't want to get rid of that. There's the wrong button. Okay. Sub. I don't want to accidentally remove something. Alright, so let me make sure it still works. And okay, yeah, so it does. So that works. So let me rename. Oops. Let me move fib.tasm to fib iter.tasm. Yeah, and then let me move fib.tim and remove yeah. So now let me recompile fibiter .tim, and there we go. Okay, so now we have both iterative and recursive Fibonacci. And it's not completely optimized, I suppose, probably, but it does work. They both do work. They do print in the opposite order, so I think. Yeah, fib, right? Yeah, so prints in opposite orders, but that is okay. We could make it print in the right order, I suppose, if we started at 0 and then added from there in the fib recursive. Let's see. It's down here in main, so we push n. We just compare it. Rather than comparing it to this, we start at 0. Could do that. But I'm not going to worry about that. I think it is good. Yeah, so that is all good. So let me push the changes now, because there is a few changes. So basically, implemented call and return, as well as return stack. Yeah, so we implemented that, and then also implemented recursive fib in examples, and renamed fib.cancel to fib iter.cancel. There we go. Whoops, and there we go. Okay, so I can push that now, and then to make sure it worked, and then yep. Okay, so that's all good. So I am quite happy with that. So let me get clean. So that I think worked well. And it does look like the call and return worked how it should work. So now we have that. Now I wanted to add some more string stuff, because right now the only way we can interact, we have two ways of interacting with the string stack. Yeah, so this is the string stack, and that's where all the strings are stored. Right now we can get a string from it and push it onto the regular stack, the data stack, I suppose. You can push it on there, push the pointer to it, and then you can access it. You can only do that, and you can push to it. We also need an operation to remove from it. So pop, and then perhaps the indexes as well. Let me actually update to do this, because I did actually do this. So let's do something like that. It's not markdown, so it's not going to work, but yeah. So these are things that I want to do. So in here, it should be fairly easy to add some new stuff. So basically, inst pop stack. So that's what we'll implement first. Should be not too difficult. So let me just go to pop, and then literally just pop stir. Yeah, that's what I want. Inst pop stir. Pop stir. Okay, so pop stir, and we can make a new function for that. Yeah, because right now we have push stir, which I think I'm going to make not unreachable as well. Basically, two use cases for that. But for now, I will not. So let me just go up to the pop function that we've got. Okay, that's not a good way of doing that. There we go. Okay, so we have pop here. So let me yank this. And then, alright, so this, yeah, this will return, so this, yeah, I suppose it will put the character on the top of the stack, right? Will it? Yeah, I guess, well, okay, so we will return machine stir stack, and this can be stir stack size. Stir stack size, there we go. Then let's call it string stack underflow. That is probably a good idea. Alright, so we return this, and this needs to be stir stack size. And that should be all that we need. So this needs to be pop stir instead of just pop. So pop stir. So let me go back to the here, and yeah, so that should work now. So now we need to implement it on the level of the assembly. So if we open the Lexer, we need a pop stir, just like this. Pop stir. And then we can add it into, let's see, we have, right here, we need right before, or right after pop stir. Yeah, so pop stir. Okay, and then that should work now. So in the parser, yeah, so the parser, we can actually find where we reference pop. Do we not? Anywhere. Oh yeah, because it doesn't actually have an operand, so we don't need to check anything for that. But in the TASM, we do have to check stuff. I think. Yeah, well, we need to add it here at least. Stir. There we go. And I think that's actually it. Because since we really just check for operands there. Yeah, so that should be fine actually. So let me see. We do have test.tasm. We do not. So let me create it. And then I'll open it up and see if I can do that. Test.tasm. There we go. And then we'll just push stir test. And then let's Tasmania. Let's go. Tasmania. Alright, nice. Yes, okay. And then we can pop stir, and then we can get stir 0, and this should return an incorrect thing. So let me actually, in the tim.c, so when we get the stir, we need to, yeah, so we want to actually pop from, well, we don't want to pop, we just want to peek from here. So, yeah, so we need to make sure that this is not, so basically we need to check, if index, who's Tim? That is the, hang on, whoops, titanium virtual machine. We pretend virtual doesn't exist, and then we take TI and M, and it's Tim. That's what it is. Tim. That's where it comes from. Okay, index is greater than machine stir stack size. That's such a stretch. Yeah, well, it's, I could have done TIVM, but that didn't sound quite right. Or just TVM. But really I wanted the I because that's the symbol for it, is TI. But TIVM, it just doesn't sound right to me. So I went with Tim, because that's an actual thing, an actual word. Yes. So it's a stretch, but I don't care. TVM sounds like a news station. That is true. It does actually sound like, yeah. Hang on. So if index is greater than that, then we want to printf error string stack underflow, and then whoops, exit 1, and okay, so now we should get that error when we do this. So I build this and we have a problem. Yeah, because it is not stack size stir. So where did I put that? Size stir. And this should be stir stack size. And build it. Okay. Tasm, and then test.tim, and we didn't get any errors. So, ooh, you know, actually, equal to. Yeah, we need to check that. So pop. Yeah, so it can't be that. Equal to. There we go. Build it again, and then run this, and string stack underflow. Okay, and if we don't pop the string, then it should be fine. Whoops. There we go. Okay, yes. So yeah, so push 1, and then native 1, and then it writes test. Okay, so perfect. So that is working now. So now we can pop from the string stack. So I was thinking, right, if we look at the to-do list here, so do we need dupe and swap for the string stack? I think it's probably a good idea to have those. So I think I'll just add them. Can always remove them later, so it's not a big deal. So let's see. So I think there is a lot of operations. So dupe, and then dupe stir, and then let's see, in dupe stir. Yeah, this is a lot. In swap, and then alright, I guess that is it. I didn't add this one. Whoops. Inst swap stir. Okay, so we have that. And then we can handle it in here. So in dupe, yeah. So dupe. There we go. Dupe stir. So we can just do the same thing, but we want to push stir rather than. I don't know if we have a push string function, so we should probably implement that. Was pop stir. So we don't actually want to pop the stir. So perhaps we should make a function called peek stir. Which will, yeah. Oh, actually, since we push it twice, we can pop it. Yeah, that's actually fine. So, yeah. So do we have push stir? Alright, so we do have that. And does it work? So yeah, but it does take that. So I think that should be fine. So push stir, so we do have that. So that should be fine. So dupe stir, and then I think that's all that we need for that. So let's do something now for this. Indupe stir, and then index dupe stir. Why is this a function? I'm not sure. Okay, but we can get to that. Dupe stir. No, index dupe, and there we go. So yeah, we can just copy what's going on in here. So why did I move this out to a function, but not with all the other ones? Because it is not. Yeah, we're just pushing the top stop. We're checking the boundaries, and yeah. All right, so I don't think I need to make this a function, but I will anyway. Yeah, because we only use it once, so it's not like super important or anything. But machine stir stack size. Stir stack index. Okay. Yeah, this can be push stir. All right, so that should be good now. So let me go back to push. There we go. And then, okay, so now we can do the same thing for, so we have indupe for swap. So swap. So pop stir, and then push stir. And that should be all that we need to do for that. And then index swap, and we're good. So yeah, this is the same, it's the same deal. Swap stir, and this actually needs to be changed to stir. Yeah, so index swap. Let me change this to stir. Index swap. Okay, so same deal. Okay, index swap. This can be stir stack size. And then this is just a char star temp value equals that stir stack, and then stir stack index equals pop stir machine, then push stir. Okay, so I guess that will probably work. So let me make sure it all compiles, and it does not. So it seems I forgot some breaks. So index swap stir. No. Index swap stir. There we go. Yeah. So let's add a break there. All right. Index dupe stir. So did I not? Oh, I didn't rename it to the right name. So yeah, index swap. Yes, this needs to be index swap stir. And there we go. And let's see, expected char star. Ooh, okay, so push stir. Yeah, so this. Oh, you know what? I know what the issue is. Because A and B are actually not char stars. So that won't work. So if push stir machine. Okay, yeah. So this needs to be. We're gonna need to do no char star. Yeah. If we do that, and this can be char, and then this can be stir 1. And maybe actually I will instead define them up here. So char star stir 1, and then star stir 2, like that. Yeah. So now then instead of the scope in here, yeah, we can just use that. So stir 1, and then stir 2. What you store in your string as a long? That is what I was doing, yes. Yeah, so now if we replace all of the incorrect ones with, yeah, so this can be stir 1, stir 1. Yeah, okay. So I suppose that is it, unless I missed some. So one set but not used. Okay, so that doesn't work. Oh, because it doesn't know the length of them. So I suppose it might be better to So, yeah. Let me, yeah, so let me see. So maybe I should, whoops, then we'll have an idea of how large they are. Because with this, they're set but not used. So, alright, just arbitrary number. It's still set but not used, so it doesn't like that. So this, yeah, I didn't actually change this. To do. And then, yeah, so that should be fine then. Okay, so one equals pop. Right, I think oh, whoops, I didn't mean to do that. I opened the file, there we go. Okay, yeah, there we go. And now, yeah, right here, this needs to be A. So I don't know why I changed that. And now I messed stuff up. So push stir, yep, right here. Whoops. Push stir. I am just fumbling around. Stir one. There we go. Alright. And okay, assign it to expression with array type. Sort stack index. Yes. Stir stack. Oh, okay, yes, so that's why we need to do this. That is 231G. So, equals that. So we need to do something like this. Okay, so now we can't test it still because it is not in the assembly. So we need to add all those. I should have just done this one at a time because it would have made it a bit less confusing. So do stir, there we go, and then swap stir, in swap stir, and I actually missed in dupe. In dupe. There we go. Okay, so now we need to add it to the keywords as well. They're not in here. Right here. So okay, in swap. In swap stir. And swap stir. Okay. In dupe. Oops. In dupe stir. Okay. Then here we need to do dupe stir. And that is it. Okay, so hopefully that all works then. And then the parser we need to check. So basically the same here. So in dupe, in swap. Yeah, so we can check type in dupe stir and type in swap stir. And then we need to update this number to be 2 larger. There we go. And that should be all that we need, because the other one doesn't have an operand, so we don't have to check for operand. And then, yeah, we'll check this here. Ooh, that's a bit of a mess. Alright, there we go. So this, we are checking in dupe, and we want to check in dupe stir as well. Or head value dot type equals type indupe stir. And then, yep, so also here, head value dot type equals type in swap stir. There we go. Okay, so then I think there is one other thing actually. We need to add it into here, which is also a mess. So inst in swap. So this needs to be inst in swap stir. And yes, it has to be in specific order, because that's, yeah. So inst swap stir, and then inst indupe stir, and then inst dupe stir, inst dupe stir. There we go. Okay, so now let's see if it all compiles. Okay, so let's see if it works. Yeah, so we know that pop stir works. Let's try push stir test 2, and then do dupe stir, and so that should duplicate the top one. So then get stir 2. Yeah, so let me run Kazim. That's not Tim. Test 2. Okay, so and then if we don't have the dupe stir, then it should not work. Yep. Okay, so that's perfect. So that seems to work. Let's try swap stir, and then we'll make this 1, and then test 2. Okay, so it doesn't look like that works. Okay. Ooh. Yeah, so it doesn't seem to set the other one back. Just like overwrites it. So that's an issue actually. Let me look. Swap stir. Yeah, so that is actually ooh, okay. Let me just make sure Alright, so that, let me add a new line so it's easier to read. So that is right, test 2. But then get stir 1 is also test 2. And 2 shouldn't exist. It does not. So, but then if we don't swap stir, then the first one is just test. So yeah, it was just, So why is that? Is the pop stir actually broken? I'm not sure it's actually setting it properly. In the push stir. Alright, let me try the index swap. In swap stir, and then we'll do 0. So yeah, it should. Right, so test, and yeah, okay, so it didn't actually do anything. Okay. So, that is strange. Alright, swap stir. Alright, let's get back to that. So, we want, yeah, so, push stir machine. There we go. Alright, so let's look here. So we are copying it. Stir stack plus plus value. Okay. So we pop the string off the machine. Well, so let me print both of them. Stir 1 and stir 2. Build it. And I forgot a semicolon. Okay, so then we'll run test.tim. Test 2 and test. Okay. Yeah, so I don't need that space. Yeah, so it does get them properly. And then it should push it, but so is it not removing it from the stack? Okay. So, yeah. Yeah, so we get an underflow when we do that. So, why does it just replace it with that? I don't see why it would do that. Because this should put string 2 on the top, which should be text, and then, yeah, so this should return text, but it returns text 2. So why does it do that? So what if we don't push anything? Then what happens to this? Alright, so that is the issue actually. Okay, so it doesn't empty the string stack. Okay. So let me in here, let's see. No, it is in the swap. Let me look at this. This one. So let's print the stir stack size. Yeah, no, I'll just put like that there. And then I'll put machine stir stack size. Alright, build that. And now, let's see, stir stack size is still 1, but it should be 0. So if we don't have anything, then stir stack size is, oh, I didn't require it. So let me do that. So we can't actually do that. So, there we go. Yeah, but now we don't print it. So, push stir text. And swap. Swap stir. Okay, so stir stack size becomes 0. So it does actually work for that. But then when we have 2 of them, then it becomes 1. Actually in here, okay. Arch, by the way, yes. Oh dang, that didn't work very well. Yes. Vanilla Arch. I installed it myself. So, yeah, even better. Yeah, so let me then do stir stack size plus plus. So let me try that. Yeah. Okay, so, stack underflow. Underflow. Yeah, so why would it be a stack underflow? So, yeah. Stir stack size is I. Does it need to be that? Alright, then we get stack underflow again. So, so why are we getting a stack underflow from that? Okay, size. Machine stir stack size. Okay. 2. Okay, so that's right. That's what we want. Because we have 2 of them. So why do we get a stack underflow when we do that though? Swap stir. Okay. Then it doesn't recognize that. Curious stuff. Okay. Yeah. So where are we getting the air stack underflow? Yes. Stack underflows give me every time in assembly. Yeah. Stack-based programming like this, like assembly, is kind of hard. So let's just kind of rule out where it would be. So if we just change this to be like that, then, yeah, well, no, that's not where it is. So that is where it is. Okay. So why are we calling pop? Ooh. So something is not right, because we shouldn't ever call that with any of the instructions that we're using. So either I did something wrong, or it is broken. Pop stir. Yeah, so we're calling pop stir. So do we get an inst pop? So let me look. Where is that? Pop. Printf. There we go. Alright, and then build it. So we don't get that. So it is calling from one of the other things. Calling pop. So what do we actually, we have swap stir and push stir. Okay. So actually in the native one, which is actually exit, native exit, there we go. Yeah, in there we do pop. So is this what is causing it? Exit, and then we'll just exit with one, like that. And then let's see. Yeah, that's okay. So that is not causing it. Okay. So where else would we be calling that? There. Because we're not calling pop here. Is it in the push stir? Yeah, stir stack side. What's the general margin size that'll work on most printers? I have no idea. I don't know. Sorry. Meh. Okay. Yeah, so that was an issue, but so we're not calling pop here. Okay, so where is it being called from? I don't understand. You're the reason we can't have nice things. I'm sorry. I apologize. Okay. So what instructions are we calling then? So what would push stir? So we're definitely not calling that. The actual push instruction. So how can I trace back where it is being called from? We don't have one of those, so I know that. Pop stir, that doesn't use that, but we aren't using that. So let's let me save that, and then let me print the list just right here, and then we can look at what we've got when we compile it. Guys, all right. So native, okay, so that is fine. Push, swap string, just a string, push string. Yeah, push string again. So that's all we've got there. So that shouldn't be an issue. Let's see. Can we print less than program size plus, and then print all the programs that we're using here. Oops. Printf. Yeah. So d like that, and then just instructions I. And then let's see. Actually, I probably want to do this in here, because this is where we're, after we read it, we can see kind of what's going on. So right here, machine program size, then machine instructions. So it's going to be just a number, but we can kind of figure out what it is. Okay, yeah, that's okay. So run that. 0, 0, 12, 1, 37. So we can compare that. Actually, if I run it right here. So 0, 0. So that is 2 nops, which that is correct because that's what the push strings become. Then 12, which is, starts there. Whoops. Yeah, 12. So swapster, okay.